Welcome to my YouTube channel, Learn to Teach Mission. Don't forget to subscribe my YouTube channel. In this session, we are going to see Matplotlib.Pyplot. It's a Python package used for visualizing a data in form of graphical plots, charts, figures, and animation. As we all know, data visualization is an effective way of communicating information to others. Data visualization is one of the important steps in both data science and machine learning for analyze the large amount of information to discover trends and pattern. Okay, and there are many libraries used for data visualization. Some few popular libraries are Matplotlib, Seaborn, and Bocage. Matplotlib it is widely used pure Python data visualization, and the Seaborn it is used for generating informative statistical graphics. It also built upon top of Matplotlib, and basically it is used for examining relationship between multiple variables. And the last one, Bocage, it is used for generating interactive plots which can be accessed as JSON, HTML object, or interactive web application. Basically, this package will use to build some interactive graph in the websites. A quick introduction about this session. Anatomy of figure. If you search Matplotlib anatomy of a figure, then the first search result from Matplotlib, if you click that, you will find the anatomy of figure. We will see in detail in the coming slide. And the next, creating a figure. Here we are going to see the component which are required to build a figure. And then some types of graphs which are available in the Matplotlib, like line plot, scatter plot, bar graph, horizontal bar, pie plot, and histogram. If you click example section in the Matplotlib library, you will find different type of graphs which are available in the Matplotlib. If you click any of this icon, that will redirect to the source code of that graph. By doing hands-on on this graph will help you to understand this syntax. Okay, will help you to understand the remaining graph which are available in the Matplotlib code. Okay, and then Matplotlib style. Here we are going to see some of the style component like font color change, font size, and many more are there. We will see in that section. And the next two section, subplot and subplot using grid spec, we are going to create multiple graph in a single figure. Like here is the example. A same figure contains four different graphs. No more theory, let's get started. Anatomy of figure. Here is our site from matplotlib.org. Anatomy of figure. The outermost line which represents a figure. Okay. And then major ticks, minor tick, y-axis label, x-axis label, title, legends are the component are used to build a figure. Those component we will see in the section creating a figure. Next, grid, color, label color, title, style, and fonts are the Matplotlib styles where we gonna see in the section Matplotlib style. Fine. At last, we are going to see the some type of graph. Here, the line graph and this dotted are the scatter plot, line plot and scatter plot. This we are going to see in the section line plot and the type of plots. Okay, let's do the hands-on. As a first step, we all have to import matplotlib.pyplot into our Jupyter notebook by using import command. Import matplotlib.pyplot as plt. Plt is the alias name for matplotlib.pyplot package. Next, we have to create figure. Here is the anatomy of a figure. The outermost line represent figure. To do that, I'm going to call pyplot package class figure, figure. and assigning it to the variable fig. Inside the parenthesis, you have to define the axis of this figure, x-axis length and y-axis length, by using fig size given 2 comma 6. 2 is the x-axis length and 6 is the y-axis length. After that, you have to define the axis. Ax is the variable for the figure fig. Actually, this line is used to partition the entire figure into different section. Like here, see, this entire image is a figure. Inside that, there are four partition: one, two, three, and four. To do that, we have to create four different axes. Here, we have to create three axes because the entire figure partition into three different sections. Okay, let me visualize this partition concept in Jupyter Notebook. Here, first I'm going to create a single partition in a single figure. We have already created a figure. Now I'm going to add subplot figure dot add subplot. Inside the parenthesis, you have to mention row, column, and then position in the array. As of now, we are going to create one partition. So one row, one column, and the position one. Plt dot. Here I am going to use plt function show to display the figure. Here is our figure because we have defined only one row, one column, and one position. If I copy and paste two more, then you will see one row, two column. Here I am changing the column to 2, one row and two column. And the last value is the position. Now we are going to have two graph in a single figure, which means two partition. Then you have to define the position for the second axis 2, and then differentiate the axis with different variable. Here I am going to use axis 1 and here 2. Okay, and click shift enter. You will see two different one row and two column. Let me change the axis of y to 4. Here you could see. And here also I'm changing one row, two column. If you copy and paste two more axes, P and 4, the entire array I'm going to have 2 comma 2. So only we can see four different partition in a single figure. Position 1, 2, 3, and 4. Here is our figure. Inside the figure, we have defined four different partition. Okay, fine. And the range 0 to 1, it's a default one. Everywhere you can see here 0 to 1 and 0 to 1. This value we can able to change it, but we will see in the next section. I hope this will give you some insight about the how to create a figure and how to partition the entire figure into different section. Let's move to the next section. Different option for creating a figure and plotting a data. Actually, there are three different types of method available for creating a figure and plotting the data. There are many more, but let me give you some insight about these three methods so that you can refer which one you feel something easy to grasp easily. Fine. The method one. First, you have to import, then it's fine. We already imported the Matplotlib into your Jupyter notebook in the previous cell. The next one, you have to create figure by using plt.figure. This one which we already seen in the above cell, so no need to any description for this line. Fig size for defining a axis length 8 comma 6, and then axis This line for partition a figure fig dot add underscore subplot and then one row, one column, and one position. Here is the method start. You have to set title, X label name, and Y label name, and X limit. It's the range. The default range we have already seen in the above cell 0 to 1, but here we are going to change the limit based on our case and then Y limit. To do that, I'm going to call the function axis function ax dot set. Say that if you click shift tab, this will populate some information where you could see some additional parameters which help us to set some values. Here it's not defining in the Jupyter notebook, but I will give you those keyword. Title. The first one is title. My first plot. The next one X label. All are small. You don't need to worry about the case sensitivity. Label X axis and then Y label is equal to Y axis, then X lim is the limit for the X axis 0 comma 5. You can define based on yours, but I'm going to give both X lim and Y lim. Limit is 0 comma 5 comma Y lim equal to 0 comma 5 and then plt dot show. Yeah, here is our first plot. Let me toggle the header so that you can clearly see both cell and graph. The title is my first plot. Here is our title and x-axis is here and y-axis and the limit 0 comma 5. The default one is 0 to 1, but now we have changed by using the option axis dot shed function. Now I'm going to plot some data into the figure. Going to create some dummy variable to array 1 comma 2 comma 3 comma 4 comma 5 and then y is equal to 2 comma 4 comma 6 comma 8 comma 10 and I'm going to set this value into the axis by using function plt inside that x comma y is the dummy value and then same. If you click shift and enter, you will see the line because we have the x limit value 0 to 5, but here you could see we have used dummy value up to 10. So you have to extend the x and y limit so that you can see the entire data plotting into the figure. I'm going to change the x limit to 10 and y limit to 10 and I'm going to change the axis size so that it will be sync and you can see both cell and graph in a single page. 6 comma 6. Here is our entire 10 comma 5. Here is our 5 value in the middle and 5. Also you could see all other data plotting into this figure. The only different you could see in the next method is here, the plotting the data. Method 2. Method 2 is almost similar to the method 1. I'm going to copy this entire line from here to below. Here we have used different keyword for the function set, but in the method 2, we are going to use different function for each keyword. For example dot set underscore title for title, and next ax dot set underscore x label, x axis, and then set y label for y axis, ax dot set underscore x lim 0 comma 5, x dot set underscore y lim 0 comma 10. Yeah, also 0 comma 10, and then you just remove the line. If you click shift enter, you will see the same image. Axis subplot is something is missing here. Sorry, here I made some mistake. X lim, same result. This is method 2. The only difference is the method 1 we have used a single method set. Inside that we have used different keyword for title, x label, y label, and x limit and y limit. But here we are using different method for each keyword, title, label, and limits. Let me see the method 3. METHOD. Method 3. It is the easiest method among others. And it almost similar to the method 2. So I'm just going to copy the entire line from method 2 and pasting it here. Remove the axis from here. Instead of calling the axis function, I'm going to call package function. Matplotlib.Pyplot package alias name PLT. And then function title. You just removed all the prefix set underscore and replace axis with PLT. And click shift enter. You will see the exactly the same result which we see in the method 2 and 3. Okay, but one of the biggest drawback in method 3, we can't create more than one partition in a figure because the axis concept which we have already removed. So there won't be options to create more number of partition, but we have a different option to create a different partition in a figure. We will see those things in the upcoming section. Among these three methods, I'm going to use method 1 throughout the remaining section. If you feel something different in the method 1, then you just pick some other method 2 and 3, and practice the remaining sections on your own. Okay, fine. There won't be any issues. It's almost similar, but there are some little bit syntax difference. So don't be worried about these methods. But at the end, you have to create the same result, same as that of other methods. Okay, fine.